So there's no other computation to do. So here, all this does is increment. Similarly, there's no other computations here. So in this for loop, plus I and I plus plus are going to act the exact same way. Now, if we were, for example, if we had an assignment here, we're assigning this to another variable, then what gets assigned to that other variable is going to be different from these two conditions. So, and then obviously we'll just print out the data once we're done returning. Any other questions about this program?
The second for loop where it says salaries I is greater than average, does that just say if it's true or false, so like 0 or 1?
Yeah, so this is a logical expression. So if it's true, it returns true, which is 1, numerically 1. And if it's false, it'll return 0. And so this is a simple way to count. So obviously here again we had the n element array that we can declare. And so we declare an element array as follows, and the elements in that array are numbers from 0 to n minus 1. And we're using all of those pieces in this program. So let's look at another example here, which we'll call backwards numbers. What we want to do is read a set of numbers from the user and then print them back in reverse. And we can use arrays to do this by storing those numbers and then accessing the elements in reverse from the way they were stored. So here we're going to start off our program with integers, and that's the number of numbers and a bookkeeping variable I. We start off by asking the user how many numbers they want to input. So we take that in, store that as numbers, and then we declare an array based on the user input. So this is a runtime array declaration. And then we go ahead and use a for loop to assign the values in that array. So taking in user input here, 1 for every element in the array. And then, so here we've written into the array, writing in from 0 to num numbers minus 1. Right? What we want to do is then read out of the array in reverse. And the way we do that is we set up our for loop conditions as follows. We set I equal to num numbers minus 1, which was the last element input into the array. And instead of incrementing, we're going to decrement I. And we'll decrement I until we hit 0. Right? So in that way, we're going from 799 back 798 all the way back down to 0. And as we access those elements, we'll go ahead and print out the values here in reverse. And then finally just an end line to finish it all. That's it. Any questions about this program? So let's go on to another example here called which digits. Here we're going to read a set of digits, and then we're going to print each of the digits, each of the scene digits once, and in their order of appearance. So let me give you an example here. So let's say the user inputs a set of digits, 3, 1, 3, 4, 1, 7, 7. What we want to do is only print out the digit once, but in its order of first appearance, right? So 3, obviously 1. We skip this next 3 because it's already been printed out. Then we print out 4. We skip 1 because it's already been printed. We print out 7, but we don't print 7 again because it's already been printed. So the way we'll solve this is by creating an array of 10 elements called scene. And so there's one element for each possible digit, 0 through 9. And initially, we're going to mark all of the digits as on the scene, right? Because if there's no user input, you haven't seen any integers yet. Then we'll go ahead and read the digits. If the digit is on scene, we'll print it and we'll mark scene. If the number is seen, if it's already seen, then we do nothing, right? Because we've already marked it and we know we don't want to print it because we've already printed it out. So let's put that together in a program. Here we include standard IO. We're going to include the standard rule library, which gives us some convenience keywords for using Boolean or true-false values. Start off our program. 3 different integers, one that keeps track of the number of digits, a bookkeeping variable I, and the digit that we're taking in. We'll set up an array of bools here, and remember, standard bool allows you to just declare Boolean variables with this keyword bool. And so this obviously has 10 elements, and we use the curly bracket initialization, which sets all of the values to 0 or false. So the interpretation of this array is all digits have not been seen yet. Then we ask the user for the number of digits that they want to input. We then go ahead and print out the number of digits. And then we go ahead and take those digits in one by one using a for loop. When the user enters a digit, we check if the digit was seen, right, by checking our array here. And if the digit was not seen, then we go ahead and print it back out. And we set the value in the array to true. And obviously it'll stay that way once it's set. And our if statement and our for loop, print out an end line, clean up, and return. Any questions about this program? Okay. Pretty straightforward, right? So arrays can be very useful for storing large data sets or for bookkeeping in various programs. So we've gone through a few simple examples. We're going to move on to some more complicated mathematical examples. We're not going to have time to finish up this discussion, but just wanted to remind you of a slide that you've seen previously. Previously, you saw how to convert decimal numbers to binary. I discussed 2 methods. One method that you've already applied and seen the program for. And this program would process the numbers from binary places left to right. If you remember the way that looked, we take in our decimal number, let's say we have our decimal number 10. We're going to compare it against our binary digits here. If the interpretation of that binary digit is less than the number, then we put a 1 there, and we go on. So if you remember, I mentioned that there was a different method, and that different method was going to work from right to left instead of left to right. And I'll go over this in more detail next time. But since we're going to be calculating our digits from right to left, we'll have to store them to print them out